Yeah, I'm fine. Okay. Let's start our discussion. Okay.
Yeah.
Okay. Do you have anything to ask before that?
No.
Okay.
Ready.
Very good. Let me share my screen.
Mm-hmm.
Let me know once it get visible to you. Okay.
Yeah. Yeah, I can see.
Yeah, you can see, right?
Mm-hmm.
Okay. Your syllabus name is or your topic name is wireless system, right? If
Yeah.
I'm not wrong. Okay. Good. Okay. We have to see the I'm going through your syllabus. We have to see the review of the propagation of radio waves, antenna theory and practical antennas, link budget calculation, radio transmitter architecture, frequency shifting, nonlinear amplifiers and their effect, oscillator and frequency synthesis, noise in radio receiver architecture, trans receiver design issue, system level design issue, and all those things, right?
Mm-hmm.
Right. So before it's starting the classes, I just want to ask you, what is wireless and wired system? Do you have any knowledge?
Um, yeah, so a wireless system would be a system to transfer like messages or data without actual physical wires,
Okay.
and
Okay.
a wired system would require wires.
Okay. Okay. Basically, that wireless system, physical medium is air, right?
Yeah. Yeah.
And for wired, we have physical medium is wire, right?
Mm-hmm.
Right?
Yeah.
Okay. Okay. Good. Wireless system and wired system. Okay. Why we go for wireless system? Aspect of
Um,
wired. Why we are moving for the wireless system?
it's more convenient. It's like
Is it
easy.
is it more convenient?
Yeah,
Okay.
and
Can you tell me?
it's maybe
Can you
fast.
tell me some of the advantages of wireless system?
Um, Let me think.
Okay. What do you mean by modulation? Do you know modulation?
Mm-hmm.
Do you know modulation?
Yeah.
Okay. What do you mean by modulation?
Um,
See,
Maybe
modulation is a process in which we translates our frequency. Okay.
mm-hmm.
We translate our frequency. Okay. Actually, in our wired system, suppose we are transmitting at 100 megahertz frequency. Okay. Or called it as 10 megahertz frequency. Okay. If we want to send through the wired system, we can send it. Okay. But if we want to send same frequency using wireless, we can't transmit it. Okay. Why? Can you tell me?
Because we have to modulate to a certain
We have to
frequency.
modulate it. Yeah, we have to modulate it to certain higher frequency because what happens that in our wireless system for transmitting in the air, we require some medium, some instrument known as antenna. Okay,
Yeah.
here we have receiver. Okay, receiver has its own antenna. Okay, It transmits the signal at the transmitter antenna, okay, to the transmitter antenna, okay. So
Yeah.
basically, Dad, we have the antenna which transmits the frequency in the air, right? Are you getting it?
Yeah.
Are you getting the concept?
Yeah.
Okay. So it transmit the message or data into the air, okay. But before transmitting the data, what we will do, we modulate our signal, okay. What do you mean by modulation? We are translating our frequency. Suppose 100 megahertz frequency, suppose we can translate it to the 1 gigahertz, so that it can be easily transmitted in the air and reach its destination, okay. So my question is that why we are doing modulation? Again, my question: why we are increasing our frequency? Can you tell me?
Maybe because of some losses or
No. Those things will come
oh, it's
later.
because of the frequency spectrum.
No.
Yeah.
What do you mean? Relation between lambda and frequency is inversely proportional, right? Lambda equal to c by f, you know, and height of antenna is directly proportional to the lambda. Can you tell me what will be the lambda for 10 megahertz? It will be 300 meter, okay. And if we'll take the height of antenna around lambda by 4, then it will be 75 meter. Is it feasible for us to have 75-meter antenna? You're thinking that for 10 megahertz we need to have 75-meter long antenna. It is quite longer, right?
Yeah.
And if we translate it to 1 gigahertz, the height of antenna will get drastically reduced. Can you tell me what will be the lambda for 1 gigahertz? Is it 0.3 meter? So height of antenna, it will take lambda by 4. It will be 0.3 divided by 4 meter. It is quite less. Are you getting it? 3 by 40. Okay, 3 by 40 is quite less value.
Yeah.
So can you think which one will be feasible? In your phone, suppose you are nowadays we are dealing in gigahertz, right? Whatever the modulation technique or whatever the bands you are using, with generation you are using, we are suppose our phone is transmitting 1 gigahertz. Want to transmit 1 gigahertz, he will require 30 by 40 meter antenna. Is it feasible, right? 30 by 40 meter is quite less. It is feasible for us, right? Right. But if suppose once ask you to send signal from your phone for 10 megahertz, you will require this much wider antenna, longer antenna. Is it possible for you? Are you getting me?
No.
No. So
No, I get it. Yeah.
you got it, right?
Yeah.
So first of the funda of our wireless communication is to have, first of the requirement to have a modulation technique. We should know the modulation. Okay. Okay. And other advantages of wireless system is that we will have higher coverage area. Why higher coverage area? Because frequency range is high here. Understood? Understood the concept?
Yeah.
Okay. Another very good thing is that they offer mobility. You can, because of the wireless system, we have the idea of the mobile phone, right? Right?
Yeah.
Okay. But disadvantage is there. Sometime it is having lack of security. Crosstalks can happen, right? Sometime you might be observing, because of the weaker signal, your phone is getting connected to some other person's number. right?
Mm-hmm.
So disadvantage of this one is crosstalk. Okay.
Yeah.
Wired system was providing security to us, but wireless is not providing. Are you getting it?
Mm-hmm.
Anything you have to ask in this basics of this wireless system?
No.
Why we are doing wireless? Why not wired? Why we are doing modulation? Why we are not doing modulation? Anything?
No, it's okay.
Okay. Okay for you?
Mm-hmm.
Okay. Now coming to the second point. I will now start telling you about the wireless system. Okay.
Mm-hmm.
Signal travels using radio waves. Signal travels using radio wave in wireless system. And your first topic is radio wave. What do you mean by radio wave? Can you tell me?
Um,
Do you have any idea of radio wave?
yeah, I don't know how
Okay.
to
I will
explain
draw
it.
the band. Okay. I will draw one. Yeah. Tell me.
I know it's like
Okay.
a sound
Okay.
with
Okay. I will draw the radio wave band. Okay.
mm,
Okay. I'm writing the radio wave band. Okay.
okay.
Radio frequency bands. Okay.
Yeah.
Okay. Are you seeing the bands? This is the
Yeah.
radio frequency bands.
Yeah.
What do you mean by ELF? ELF is the extreme low frequency, extremely low frequency. Okay.
Mm-hmm.
It is extremely low frequency. Extremely low frequency. This is super low frequency. This is ultra low frequency. Okay. This is very low frequency. Okay. This is low frequency.
Mm-hmm.
Low frequency. This is medium frequency. This is high frequency band. This is very high frequency. This is ultra high. Okay. This is super high. And this is extremely high frequency. Okay. These are the radio bands. Okay.
Mm-hmm.
Any doubt?
No.
Okay. Every broadcasting devices, every mobile radio, every navigation that devices are allocated with different frequency. Okay. so that those frequency will not overlap with each other. Are you getting my point? So that those frequency will not overlap upon each other and they can transmit the signal without having interference. Are you getting the my point or not?
Yeah.
Okay, very good. Okay. 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 Now these were the radio frequency bands, signal travels. Okay. Now what happens that when the signal travels, from transmitter to receiver via a air medium, it means that radio waves are traveling. Radio waves are traveling. And these radio waves suffers losses due to many factors. Okay, these radio waves suffers losses due to many factors like atmospheric loss, line loss. Okay, this type of atmospheric loss, line loss, attenuation. Okay, these type of things are being there. Okay, are you getting my point?
Yeah.
Okay. Okay, these was the I'm just giving you the brief ideas of what is wireless. Okay, how things are being communicated. Okay.
Yeah.
Okay, you can see this is our transmitter. Okay, and this is our information. Okay, and there is our antenna. Okay, and this is again our receiver, and there it also antenna. Now you think that we are transmitting a signal from transmitter. Okay, this antenna will catch the signal, right? But this antenna will transmit the signal in every direction, right?
Yeah.
Right or wrong? And in our spaces, in our air, in our surroundings, we have many receivers, right? Right or wrong?
Yes.
But this transmitter wants to send signal to this antenna only, right? So what should be the nature of the antenna? So that this antenna should send signal to this receiver only. What should be the nature of antenna? Can I say that directional antenna is needed? Have you heard about directional antenna?
Yeah.
Is needed in wireless system?
Yes.
So that point to point communication can happen. Could happen. Are you getting this concept? Are you getting this concept or not?
Yes, I'm getting.
Okay. Now I will derive one formula. Frisch equation. Have you heard about Frisch equation?
No.
Do you have your previous paper question paper? Previous year question paper?
Yeah.
Yeah. After the class, can you send me? Because with the class, we can do some couple of examples from your previous paper. Okay.
Yeah.
That will be good, right?
Yes. Yes.
Okay. Today we will see Frisch equation. Okay. I must think that this will be this question can become in your examination, this type of questions. Okay. Now see, this transmitter, we are transmitting some power, some information from this transmitter. Okay. So this transmitter will transmit PT, right? And this receiver will receive PR, right? Agree?
Mm-hmm.
Agree or not?
What's PT?
Okay. PT means transmitted power.
Okay.
Okay. And PR means received power. Okay. Understood? So this transmitter is transmitting PT and it received by its antenna. Okay. Transmitter's antenna. Okay. This is transmitter antenna. So this transmitter antenna will have also some gain or loss, gain in the antenna. That gain is I am denoting by GT. Okay. Okay. Observe it. This equation is very important. And this antennas will receive PR, right? Okay.
Mm-hmm.
And this antenna gain at the receiver will have ZR, right? Suppose this is your phone. Okay. This is your mobile one. And this is your friend's mobile too. Okay. You wanted to send signal to him via Bluetooth. Okay. Assume it via Bluetooth. Okay. How the signal will transfer? Right? And suppose the distance between you and your friend is 10 meters. Right? Agree? And how you will transmit the signal? Your phone transmitter will transmit the signal, right? That will of the power PT, right?
Yeah.
And that PT will be transmitted via an antenna of the GT gain, right? So at this point, the power will be PT into GT. Agree or not?
Yeah.
Agree or not agree?
I don't know.
Agree? Okay. Oh yeah, what you are not getting? Tell me.
No, I don't know the formula, so I can't say I agree.
No, I'm telling you. No, I'm telling you. Suppose this is your one device, okay? And you are telling that I have sent its 2 volt signal to it, okay? And this device is providing gain of gain of 4 volt. What will be your output? Can you tell me? Can you tell me?
8.
Isn't be 8? You are sending 2 volt, okay?
Yeah.
And to one device, okay? And that device is providing a gain of 4 volt. Okay, so isn't we that the output that you will receive will be 8 volt?
Mm-hmm.
Are you getting it or not? If you're not getting, you have to understand it carefully. Otherwise, whole wireless system will be some alien subject for you. You have to understand it. If you're not understanding, ask me where you are not understanding.
I understand.
You understood that if we are sending a signal of 2 volt to a device having a gain G, and that G is 4 volt, so our output will be 2 into 8, that will be 4 volt, right?
Mm-hmm.
Right or wrong?
Right.
Suppose in place of 2 volt, I am transmitting PT signal, okay, and this device is nothing but this is antenna, okay, this is antenna with gain GT. What will be the output at the antenna? Can you tell me? Can you tell me what will be the output at the antenna?
GT.
Sorry, can you tell me?
GT.
Very good, very good. It will be PTGT. Okay. It will be PTGT. Okay. Understood or not?
Yes.
Okay. Understood? Now, this PTGT have to travel one distance D. Okay? Had to travel one distance D. And it has to reach at this point before the antenna of the receiver. Okay. So can you tell me what will be the power at this point just before the receiver of the antenna of the that one?
PRG.
Yeah, of the receiver antenna just before the receiver antenna. Can you tell me what will be the output here?
PRGR.
No. PRGR, we want PR, but here the output will be PTGT
Oh,
4 pi D square. Are you getting me? Because this signal PTGT travels D. So the power density, this is the power density. Power density at any point D from the transmitter is PTGT 4 pi D square. Agree or not?
mhm.
Agree or not?
Agree.
So can you tell me what will be the PR now? Now you think as a reverse direction. This is your receiver antenna, okay? Okay.
Mhm.
And this is your ZR. And you are getting some PTGT 4 pi D square signal here. So what will be the here output? Here output will not be PTGT GR by 4 pi D square. Will it not be? Are you getting me or not? This equation is very important.
No,
Are you getting this equation or not?
we don't have D there.
This is the D. D is the distance between. That I told you. D is the distance between your mobile phone and your friend mobile phone. That I assumed as a 10 meter. So as a generalized term, I wrote as a D.
No, I know, but between the GR and like the GR antenna and the receiver, there's no big distance, so we don't need that.
Yeah, it is D distance. I assumed it is a D distance. Okay. So PTGT, and after that we are passing it to a device. Okay. That device is the antenna, receiver antenna. That will give us GT gain. Are you getting GR gain? Are you getting me or not? If you're not
So,
getting, I will try to explain you in some other way. So this
so,
will be our PR.
so that last formula is at the receiver.
Right. That that last power is the power received formula at the receiver. Can you? Are you getting me or not?
Yeah. Yes,
Any doubt? If you have any doubt, you can ask me.
and that's power of the receiver. Okay.
Okay, understood or not? Okay,
Understood.
understood or not?
Yes, understood.
Okay, let me write in a good way. Okay,
Mm-hmm.
so I am rewriting it. This is our transmitter, okay? And this is our receiver, okay? This is our PT, and the gain of antenna, I am writing ZT, and this is D distance. This is gain of antenna GR, and we are getting it here PR, okay? So I am telling that PT GT 4 pi D square into GR equal to PR. Are you agree with it or not?
Yeah.
Okay. Agree, understood, right?
Yes.
Where PR is receiver power, PT is transmitter power. Do you know what is receiver and what is transmitter?
Yes.
Okay. GT is transmitter antenna gain. Okay. GR is
Gain at the receiver.
his
Receiver antenna gain.
receiver antenna gain. Okay. D is distance between receiver antenna and transmitter antenna. Okay.
Yeah.
Okay. Okay. Understood this concept or not? This concept
I
is known
understand.
as the Friis equation. Okay. This concept is known as Friis equation. Okay.
Mhm.
Okay, I'm writing the statement of the Friis equation here. Okay, Friis transmission formula can be used to study RF communication link. This formula is used in situation where distance between two antennas are known and suitable needs to be founded.
Mhm.
Using Friis equation, one can find antenna gains needed at either at the transmitter receiver side or mid to certain design. Okay, that is the thing. I'm giving you one question, you have to find the values. Okay, I'm giving you one numerical. Okay, and from tomorrow you will send me your next class. Before the next class, you send me your previous paper all. Okay, we can go through it. Okay,
Yeah.
do you have now your previous paper?
Yes, I do. I don't have now, but I'll just
Okay,
need to.
okay,
I will send right after this class.
yeah, yeah. After the class, you can send us so that we can practice the question paper that being came in your exam. Okay.
I think the questions in the question paper are much harder. I think we'll have to, go through
Yeah,
some
yeah,
of.
yeah. We can study a thoroughly. We
Yeah,
can
yeah,
see the
okay.
of yours, which all topics are coming there. We will study those one, right?
Yeah, yeah,
There is no issue. But first you send me your syllabus. Otherwise,
yeah,
I will teach you the random things that I am knowing that in the wireless system. But a subject is a ocean like of thing. Okay. In every topic, there are many subtopics. Okay. But I'm sure that Friis equation must be there. I'm 100% sure. Because
yeah,
wireless equation system without Friis equation is not possible.
yeah, yeah.
Okay. I'm giving an example and question to you. An engineer is designing a communication link, okay,
Mhm.
at 3 gigahertz, where the receiver, okay, for transmitter power, okay, where the receiver, Okay, ZT 4 pi. Okay, where receiver is 1 kilometer away from transmitter. Receiver antenna gain is 8 dB and transmitter antenna gain is 10 dB. The transmitting power level is 25 watts. What will be received power? Can you answer me? First, read the question carefully and try to think.
So an engineer design a communication link at 33 gigahertz. Okay, so I can write down what I know first.
Sorry.
So I'll write down what I know first.
Yeah, write down the what you know.
So for what's the 3 gigahertz? What can that?
And one more thing. This is not full Frisch equation. This is the half Frisch equation. I will derive this Frisch equation in the full. Once you do this question, I will just writing it the full Frisch equation like that first. Because what will happen, this signal will be sent here and it will be again received by this one. You are sending your signal to your friend and your friend is again, and that will be our original received power. Okay, that equation I am giving you. PT, GT, GR 4 pi D lambda square. This is the actual equation. Okay, you have to concentrate on this equation. Okay, so our PR will be PT, GT, GR. Now 4 pi D by lambda square. This is the equation that you have to use. Okay, now think about it.
Okay. So I have the power of the transmitter, I have gain of the transmitter, I have gain of the receiver,
Right.
I have distance, just lambda, I'm not sure. What is this 3 gigahertz? What would that be? Is that
This is the
lambda?
frequency.
Oh yeah,
Yeah,
that's one.
frequency.
Yeah. Oh, okay, so that would lambda would be C over F.
Yeah.
Yeah, so we just put all of that in and we get 0. I will calculate.
You got all the values. Can you tell me what is PT?
Just a second. Just need to get my calculator.
It is 25 watt, right? GT is 10 dB. GR is 8 dB. Lambda is unknown. Frequency is 3 gigahertz. And D is 1 kilometer.
So it's PT25. Or just a second. So it's is it 1.27 times 10 to the power of -7?
No, first tell me in GT, what you will write for GT? Will you write in DB or you will change it?
Oh yeah, do I have to change? I have to change it.
Right? So 10 log GT will be 10 dB. So small GT will be anti-log of 1, it will be 10. Okay. But GR will be 10 of anti-log 0.8. So you have to find this anti-log first. Okay. And lambda will be C by F. You have to find lambda first. Then you have
I
to
know.
put all these equations, all these things in the equation and you will get the values.
Yeah.
Okay.
Mm.
Are you trying it?
Yeah, I done that. I just put the wrong. I just put 10 and 8 instead of 10 and is that 10 to the power of 0.8 or what?
Right.
So it's 9.99 times 10 to the power of -8.
Yeah, around around that much you will get the answer.
Okay.
यहाँ चेयर पे रखे हैं बाकी कौन से
Okay.
Yeah.
Okay. In this way you have to but that phrase equation is little bit inappropriate. I have to derive this one. Okay, I will derive it right now. For this I was just trying to say you how it is getting it. Okay. So okay, you got it, this phrase equation, right? Formula. But yeah, the concept I am giving you here once again I'm trying to tell you. This is our transmitter, right? And this is our receiver. Okay. And one more thing about antenna I wanted to tell you about is effective area. Okay. Suppose this big is your antenna. Okay. This big is your antenna and your antenna is receiving something. Okay. Your antenna is receiving something. So in that way, we will consider that what will be the aperture of the antenna. Aperture area of the antenna. What do you mean by aperture area? That effective area of the antenna. Okay. That effective area of antenna will tells you that how much of this signal will get will this antenna will take on.
Mm-hmm.
Are you getting the concept? Because in our surrounding there are a lot of signals. Okay.
Mm-hmm.
There are a lot of signals, but depends upon the size of antenna, that much signal will be transmitted. Okay, that is denoted by aperture AE of the antenna, and that formula is lambda square by 4 pi into gain. Are you getting it? That at the receiver side we have antenna, and we considered that antenna has an aperture area AE, and that being denoted by lambda square by 4 pi into gain. Are you getting the concept or not?
Yeah, I'm getting.
Okay. So basically, I want to tell you that this is our transmitter. Okay. And this is our receiver. Okay. So we are sending our signal PT here, and we have a one antenna GT here. Okay. And we are sending the signal to another antenna GR, which is placed at distance D from each other. And so what will happen? This transmitter will send a signal of PTGT into the air, and the signal that being received here will be PTGT by 4 pi D square dash. And this signal is known as power density. Power density of signal. Okay. And we will get PR equal to PTGT 4 pi D square into aperture area.
Mm-hmm.
Okay. Into aperture area of the receiver antenna, and that we can write it PTGT 4 pi D square into lambda square 4 pi into gain of receiver. Okay. And that we will write PR equal to PTGT that 4 pi square D square by lambda square into ZR, and that we will write PT GT GR 4 pi D by lambda square. Okay. This is our transmitted power. Understood? And using Friis equation. Are you getting the concept or not?
Yep.
Okay. Can you tell me what is the loss in the signal?
What is the loss?
Yeah, loss in the signal.
So that's like what hasn't been transmitted.
That hasn't been. And what you have transmitted?
What?
What you have transmitted? Which power you have transmitted? PT, right?
Yeah.
You have transmitted PT and you are receiving PR, right?
Yeah.
It means that suppose you have transmitted 10 kilowatt and you are receiving 1 kilowatt. How much power has been lost?
9
But
kilowatt.
10 by 1, that is how much you can think like that. Almost we are receiving 10 times of power.
Mm-hmm.
Are you getting it? In the ratio, I'm telling it. The power that being lost it is I will tell it that it will be PR into PT, because we will deal in the that one into dB. Okay, loss of power in dB, and that will be 10 log of this one. Is our loss. Are you getting the concept?
Yeah.
If you're telling that loss of power is PT minus PR, okay, if we will write in the dB, it will be 10 log PT minus PR equal to 10 log PT by PR. Okay,
Mm-hmm.
that is the losses, right? Loss equal to PT by PR. Okay, understood?
Mm-hmm.
Okay, getting me or not?
Yes. Yes.
Okay, so this is the loss of the signal. So can we write loss equal to 10 log PT by PR and that is equal to PT by PR will be this will be this much 20 log 4 pi dy lambda. We are considering loss after the antenna. Okay, we are considering the loss after the antenna. Whatever the loss in the free space. Are you getting my point?
Yeah.
Loss in free space equal to 20 log 4 pi by d lambda. Okay.
Mm-hmm.
Are you getting the concept or not?
Yes.
Okay. Can you tell me if distance will increase, loss will increase or not? By this formula?
What?
By
Yes.
this formula, can we say that if distance will increase, loss will also increase?
Yeah.
Are you seeing it in practical case? Suppose you are sitting here and your friend is sitting here and you are talking to him. There is no loss, right? There is little bit loss. And suppose your friend is sitting here, she will not receive your voice, right? He or she will not receive your voice in that in that good manner. Why? Because that your voice suffers from losses because of that it travels a lot of distance because you guys are sitting apart from each other, right?
Yeah.
So losses in free space are being indicated by this formula. Okay, 20 log 4 pi d by lambda. Okay, getting the concept or not?
Yes.
So if I'm telling you that a system has transmitter, a system transmits at 1 gigahertz and are placed 1 kilometer apart from receiver, what will be free loss in the communication between transmitter and receiver? Are you getting it?
Mm-hmm.
A system is transmits at 1 gigahertz, okay? 1 gigahertz and are placed at 1 kilometer apart from receiver. What will be the free loss, free space loss in the communication between transmitter and receiver? Okay.
Yeah.
Can you answer it? We know the formula of free space loss. Free space loss L equal to 20 log 4 pi d by lambda. Okay. Can you give me the answer?
So 20. Wow. What's the frequency?
Frequency is 1 gigahertz.
12.4. $12.4.
Okay. Is it 12.4?
Yeah.
I have to check it. I have to check it. I don't have the answer right now with me. I will let me check. That is 4.18 equal to 0.682. No, I think the answer is a little bit different, but you can find it by this manner. Okay, answer can be a bit different, but you have to use this formula. Okay, this is anti-log formula, and this is the loss formula. Okay, so basically, I have given you two concept of freeze equation formula and loss equation formula, right?
Mhm.
Right? Okay. And I told you why we are using wireless, why we are not using wired. What are the and in the next class we will see the some of the more advantages of the wireless system. Okay, and we will see that how much that what else question are coming in your examination. Okay, I think you must have the 5 to 6 years sample paper, right? 5 to 6 sample paper of your
Yeah.
previous quizzes or examination, right?
Yeah.
Okay. So before the next class, can you send me those papers?
Yeah, I will send now when we get off the call.
Okay, sure. Once you send me question, then in the next class we can discuss those paper, and we will see that what extent your syllabus is there. Okay, so we can deal with the further topics. Okay.
Okay.
Okay. Till then till then you can practice and tell me if you have any doubt. In the next class we will discuss it. Okay.
Thank you.
Okay, got it. Thank you. Bye. See you. Have a nice day.